Okay, good evening, everyone. Welcome to the February astrophotography meeting. I'm going to take a quick look at the agenda. I can find it on see the agenda?
Not yet, but it looks like it's happening. There it is.
There it is.
Okay, well, we're going to start out with just open questions for the experts. Then we're going to do some quick presentations by Steve. Well, not just a quick presentation by Steve on a couple different topics. John and I are going to give updates on our Bernard Sloop project. John's got 42 slides now on the multi-scale gradient correction. And then Rick's been doing some work on the JNWST. So having said that,
Is that the order we're going in?
that is the order. You want something different?
I'm not going after John's 40-something slides. No, I'm not going to be awake that long.
It'll be worth it. He's exciting. So are you being serious or?
I'm serious. I'm not going to stay up that late.
Okay.
It won't take that long.
I mean, we don't have to do mine.
Oh, no. Let's do
Not
this.
that much.
Well, it's not a big deal. Let's just change the order.
It don't matter.
You got up early this morning, I suspect, and
I did.
why?
I got to be up early again tomorrow morning.
Okay, let's do this. Let's ask. Is there any questions for the experts? And if not, we'll just get right into Rick's presentation.
Well,
Anybody?
I got one question. It's more of from a beginner's point of view of how do you organize your data? When I started, it was, you got a single camera. Here's a day I went out. So I got 2014, 01, 01. And there's all my data shoved in that folder. Next day, put the next date down, next date down. Next thing you know, I've got a whole 30 or 40 or 50 dates for each year to go through. So then I started putting folders in within the date saying this is M42, this is M43, this one's whatever within the date time. And then so the next year you start adding more. So as you're adding more and more, you're getting more and more complexity. You start realizing that it started out great, but now it's like, where's everything at? What did I use here? What filter did I use? A filter, a clip-on filter, anything like that for this data here? Since you don't record a lot of that stuff, you got to sit there and think, well, did I start using it then or that? And then so now I'm kind of restructuring everything to go more toward this is the object, and then underneath the object I'll go through and now separate out if it's multiple cameras to use this camera for this camera for this data type thing. So just kind of wondering how everybody else does their organization of their data.
I think you should do it by target first, then camera second.
Yeah, that's what I'm moving toward to do that. But it's just funny how you start out. You just throw data in. You got, I have a DSLR and a lens. Okay, I don't need anything else. Now I got a telescope. No, I don't use that no more. So I'm using this telescope. Now I got two telescopes. Now I got this. Now I've got that. And you just keep on adding on, adding on. Next thing you know, 5 years in, you've got 3 telescopes, 2 or 3 different cameras, and you're going, where's everything? What started out organized is now unorganized. When you think about it. So.
I was at camera first, then telescope or focal length second, and then target third, and that was stupid. Then I
said, okay. Be real obsessive. You should create a spreadsheet and have all your image titles in there. This is what I used to do with 35 millimeter frames. I'd take my notebook that I had out in the field. I had my film labeled, numbered. I had all the frames counted. And I created a spreadsheet with basically that had my notes for every frame that I took. And over time, the target, how long the exposure was, what the temperature was that night, what, all this different things that I made notes about. And over time, you wind up with a reference data set. You go back through and say, okay, if I want to take all the M42 pictures I ever shot and do something with them, maybe combine the data or something, then they're all in a spreadsheet. I just go look them up and pull those file names.
Yeah, that's what kind of got me to where I'm at reorganizing stuff is okay, I know I've done M42, usually almost every year. And I go
Yeah,
back and look at this data. I say, I can take that data and combine it with this data and this data. I can, it's the same scope I use over 4 or 5 different years. I'm going to combine all that data to make more hours of the data, basically, see what else I can get out of it. So, and I thought about that, in the past year or so. It's like, I need to reorganize, I started a projects folder when we started doing the Fleming's triangle and all that. So I figured, okay, I created a projects folder. Here's a Fleming's loop or Fleming's triangle in there. And I started adding other stuff into it as I was going along. And then, so now was still doing the other way as well, just copy the data out and move it over. Now I need to reorganize. And so I figured go to
Photoshop.
target first.
Photoshop had a program called Lightroom
Yeah.
decades ago that kind of would start that cataloging process for you,
Right.
and you could add notes to it and everything. And there's actually another one that there was anyway, I don't remember what it was. I've since lost track of all that.
But the intention is you're going to combine them all, John?
Yeah, I basically was going to like do a M42 folder just as an example, and then find all my M42 data and put it in the folder. And I can organize it, by camera, by telescope, whatever, and try to get everything at least organized, and start looking at maybe trying to combine stuff. But I got like a crap ton to go through because I'm sitting there looking to count up on my share that I have for my telescope pics. I'm already at over 3,000 files and 18 gig at the moment, and it's still climbing. It's going to probably go to a terabyte or so, but the only thing I throw away really is when I do the videos, because videos take up so much space.
Right.
And you can eat a terabyte up with 80 something videos easily. So once I've stacked them and got my final or the results of the stack, and I'm satisfied with it on the different varieties of 10%, 20%, 30%, or whatever, then I don't find myself really going back and restacking. And then I'll go back and delete the actual AVIs and the CR files, get rid of those. That saves a lot of space. But as for all my FITS files and my DSLR files, I got every one of those back to 2014 when I first started. So
There's a bunch of stuff stacked in front of it, but I have boxes over there in plastic container boxes with all my rolls of film that the negatives chopped up and in them and labeled sequentially, so that once I refer to that spreadsheet, then I could go find the negatives that were in those boxes.
Well,
but I just figured I kind of bring it up from a beginner perspective. If you're going to start down this little journey of money pit, what do you want to ever call it?
it's,
You're going to collect a bunch of data, and if you don't organize it early, it's a pain to organize it later. So you might want to start thinking about how do you want to keep your data organized. You want to go by project date. You want to go by the actual target time. Target, you separate that by telescope, to separate it by target or whatever. But you bring out something to think about how you want to organize it so you can find stuff later. That was the problem I had, trying to find stuff later. It's like, 3 years ago I took M81, M82, and I had to go back and look at folder after folder after folder to find. Okay, I did it back in March 3rd of 2021. I got 2 hours of data that I can combine with the 16 hours of the HA and O3 data I took when I was doing when our project that we're doing with the Barnard's loop. So when it was going down and it was getting too low on the horizon, my scope would flip over to do M81, M82 in the HA03 filter. So I have 16 hours of HA basically out of that. And that's what part of this here is. It's the red on it. It's part of that 16 hours that I combined it.
that's really nice.
And I still got another data I have found I got to add to that. So that's what got me going to reorganize and get rid of all the individual date folders and take out the targets out of it and make a long target list. Then you break up the targets. You want to make it up by Messier, NGC catalog, and then stuff like that, or you want to just keep it just one straight list, because the more and more you do, the longer that list gets, and now you're gonna have to manage your projects. It's like a never-ending cycle.
It is.
One of the best ones I've seen, Gary M. Remember, he was one of our presenters a couple of years ago. You go to his whatever the website is that people use, AstroBin. he's a tremendous organizer. So Gary, he would be a good example if you wanted to copy somebody. Okay. Any other questions for anybody? On any topic right now for the brains that are on our group? Okay,
Um,
go ahead.
I
Sam.
I just wanted to say that the last program we had, the session that, and I guess the one that I had with you and Steve together, that multi-scale transform and the local histogram equalization, boy, they make a difference.
Yes,
They do,
yes,
yeah.
That was amazing.
yes,
This
they-
last one I did.
cool. Well, have you posted it on the Slack channel?
Yeah, that was my Rosette Nebula.
Oh, yeah.
Is in there. Yeah,
It's good.
yeah, it turned out great.
In fact, I even downloaded it and played with it myself too. So, okay, I gave up sharing, Rick, so you can do the sharing. You want to talk to your JWST work, and then we'll get back into the order of the agenda.
All right. Let's see. Share. All right. So, to be clear, referring to what I've done as work is being generous. There was a magazine article a couple of months ago. This issue of Sky and Tell, and basically it's process your own web images, right? So I thought, well, that's kind of interesting. I mean, I've played with some of the Hubble images before, but so I thought, well, I'm going to dig into this. And they have some instructions about how to go about finding the files, and their instructions, I still haven't been able to get them to work. So that's so much for that. I'm not sure something hadn't changed since then, too. But let me show you some basics. And I told Meryl the other day, really what I'm hoping to do is show you the door to the rabbit hole I found so that y'all can go dive down this sucker and then show me around sometime. So there's the primary website for this, for all, in fact, it's basically the primary website for all the NASA funded and European Space Agency, anything that NASA or the American taxpayers had some contribution in. The data files are available through a website called MAST, M-A-S-T, STSCI.edu. And this is the primary website. If you ever just type in MAST this much, it'll get you to the portal. That's really what you need. And there are videos and instructions on how to go about retrieving data. There were instructions in the magazine article. But the bottom line is you basically type in your target name and go back over here where I've already done that. And I thought, well, M42, okay, I'll just go look and see what they got. I don't know what they got. I poked around here for hours trying to filter down. I think if you get, M42 yields 601,143 files. So you want to trim that down a bit. You go to select the James Webb Space Telescope. That was the first thing. The mission. You can do Hubble, HST. I was looking at JWST data. And so I started looking at, the more and more I started looking through this long list of files and stuff, and long before I started to understand what a lot of this meant, I did spot some called trapezium, and I thought, well, now that's cool. Let's go see what we got in that trapezium. show up here at all. Yeah. Anyway. Yeah. Trapezium cluster right at the top of the list here. So I thought, all right, well, let's try to filter down to that. And I did, and this thing is slow as Christmas. But I wound up figuring out how to download these 12 files, trapezium cluster. They're all infrared images. And so I got the big data sets downloaded. And I thought, well, okay, let's go look at what those look like. And they're huge files. Let me get to that real quick. Should have gotten prepared better. Okay. So, so each one of these image files creates a zipped folder of data sets. And once you get that downloaded, you can dig into it. You open it up, there's another folder, it's all uncompressed. Okay, there's an HTML document. This is manifest, right? So this tells you that there are 5 files in this thing and gives you some information about them. I'll go into that in a little more detail in a few minutes, but you open that up and you got this. This was the 140. Yeah, this is the 140 with the 212. These are combination filters. So you open this up and there you go. There's a fits file right there, 25 gigabytes. So you open that up and I'll show you what that looks like in PixInsight.
I think that's 25 meg.
No, it's 25 gig. It wasn't 25 meg. No, it was maybe maybe you're right. Was what was it?
Is there a K at the end or not?
Yeah, you're right. 25 meg. That's right.
Yeah.
So um, anyway, they're pretty good size. And let me just open one. It's not the same one, but it'll make my point. Here's what opens.
I don't know. If you expand the little column out at the end, it should show if it's a K or not. The one below it showed like it was a K on it. That was like a gig size. So this one could be 25 gig.
I don't know what you're talking about.
This, when you look at the size of the folder, the file in your folder list.
Okay, this is what you get. And if you got 1, 2, 3, 4, 5, 6, 7 files that opened up. So let's do a quick expand on that. And that one, I haven't studied these enough to really know what that's all about, but that one wasn't something I was going to be able to use in my initial thinking. This, I'm starting to figure out more about what this is all about. This is the panels and the different instruments. So this is raw data. No thanks. I'll move on to something else. This is a similar thing. It's got all that cross hatching. There's another one like that. This is some kind of mask for some reason. I don't know. Here's another one. got all this cross hatching in it. And lo and behold, in every one of these, there's one that looks like that. So this looks good enough to make something out of. And uh, and so out of all those 12 files, this is what I wound up with. So I got 12 shots of the trapezium. Some of them have these masks, and I'm guessing that those masks are the result of overexposed stars. The trapezium's right here, and this part's going to be really, really bright. And so, given whatever filter or something, this could be blowout. It could be, I don't know what it is, but it's certainly some kind of processed data that's been dealt with already. So I got 12 of those. So since you can only put 3 of them together at a time to make 3 different color channels, I got to thinking, well, what do I want to do? Which colors do I want to deal with? So I started looking up the different files, and it turns out that if you go to the James Webb, just type in James Webb docs or something, this was easy to find. And you come down here, you can get to the filters, and this is that cross hatching business. This is what's up with all that. I don't know what that means yet. I just found it, started looking at it. That's the filter wheels, but here are the filters, right? And NearCam is the one I'm using. Their data sets, NearCam, and these are the different filters. So you've got some wideband filters, long wave and short wave. You've got some, these are considered wide as well, I guess. These are mediums, and there are some narrows. And some of these have got are a combination. Most of the pictures are a combination of clear and one of the filters, and some of them are a combination of one of the filters and one of the narrows. So, trying to keep all that straight, I decided to create a spreadsheet. So, this is a spreadsheet of the image files I'm working with, and one of the things I've got to deal with is getting them sized the same if I'm going to try to get them mixed into a single image. So I got a handful that are one size and a handful that are twice the size, basically. And but here's the filter data. So this is the filter data. I just created a table out of it, and these are the ones I have a copy of. So this is the picture title, and so each one of these see clear, and this is a 115 wide clear and a 140 wide. This is a 150 wide with a 162 M. I'm not sure why they do that, but those are the data sets I've got to work with. And you go back over to PixInsight, one of the ones that seems to have the fewest number of holes in it is this guy, which is clear and a 140 medium filter. So 140 medium filter right there. So anyway, that's kind of where I'm at. What I'm going to do is try to find some the right size images. That's the next thing I'm going to get over here to this page with filters that are maybe adjacent. For example, maybe this would be fun to put the three together, right? But I don't have a 356W. I've got the 277W and the 444W. But in the 300 range, I've got the 335 medium and the 360 medium. So I instantly jump down here And now I've got 4 colors instead of 3. So what I may do is maybe start with, say, this guy and these two and see what that produces, that sort of thing. Anyway, that's kind of where I'm at with it. There's lots of stuff there. There's lots of, just pick your target, and the James Webb Telescope is probably taking a picture of it. Plus, once you get that data, all of these systems are basically coordinated around their coordinates, where it is. So if you got something that the target name works out in one image set and you don't find it in another, look it up by location. You may have that location caught by a different satellite anyway. And there are, it's not just the Hubble Space Telescope and James Webb. There's Spitzer, there's a bunch others. And like I said, just for the M42 alone, there's 601,000 images. Anyway, it's going to be an interesting rabbit hole to go down and play with, and that's about as far as I've gotten. So, as time allows, or one of y'all get out in front of me with it, then y'all can show me around better next time. That's all I got, Merrill. Thank you.
Yeah, is Adam on board? I mean, he's the one that would probably lead the way. I wonder if they can do the Bernard's loop. Just kidding. Yeah, I think it's a good opportunity to get data that we can, since it's cloudy skies between now and June, I think. So, any questions for Rick before we move on? No? Okay, that's weird. Okay, Steve,
All right.
you're up. You're going to talk to us about your must-use technique first.
All right. This is data that we stacked. That I stacked here. And this is a hat tip to Frank at SETI Astro. He's a pixel math genius, and he noticed with one shot color he got a lot better results if he just did one simple pixel math equation, which you can do. I'm going to do it in PixInsight, but you can do this in his free suite. He now has pixel math in his SETI Astro suite. And it's really a simple thing. The only thing you have to remember is min for minimum, MIN. And I'll just demonstrate real quick. I'm just going to call this the stack. And this is the pixel math. And let me just open up an intensity. Let's do.
So you made a clone there, so what you did?
Yes. And let's look at this data here. This is the linear data. Hadn't been stretched yet. And you see how, the green, this is green because this green is out front in the histogram. And I've heard, not only have I heard Frank say this, I've heard Adam Block say virtually all of this is crap data. And the fact that it's there is actually hurting some of your processes and stretches. So what Adam Block says in one of his videos is you click about right here, you just a little bit, looks like data starting right there. You go to a little bit to the left of it, and you choose linear. And watch black point when I said send to BP to there, and see how that changed. And I'm going to drag this, reset everything.
So you're using the GHS.
Yeah, and I'm using the linear. I was using linear to do that. And you see how everything moved left.
Right.
So that this is much better data to begin with. Well, he has a better method than even Adam Block does. Frank at SETI Astro. So I'm going to go back to where this data was. And I'm going to open up Pixel Math. And remember, I said the only thing you have to remember is min, but you also have to grab the name of the file you're doing. I called it PM here, if you see over here. So I'm going to do PM minus min PM. So it's going to take the minimum pixel value, which is the darkest pixel value of each of these channels, and it's going to not clip any data. It's going to move linear, in a linear way the data to the left without clipping anything. Nothing's clipped to the right on the highs, lows, or mids. And if you look here, you see this big gap. I'm gonna just run this. You see how everything went left and it got a lot better aligned. And the color's more neutral. So this was the green. And this is a result of pixel math. And he says this is your starting point. And as many of us know, you can go to your blue channels. Let me reload that. Man, that's kind of weird. Well, anyway, you can move your blue channel left and right to make the color, the plateaus equal, and it makes it a neutral image.
You can do that histogram pretty easy.
Yeah.
Well, okay. Why do you limit this to just one shot color? I mean, would this be the same for once you did channel combination?
Well, I think he was doing a one-shot color demo, and maybe it's the first time he did it. But that's a really good question. So I decided to do what you suggested, Merrill.
Oh, you okay? I knew that.
And I'm going to demo that real quick. But I was also going to point out something very interesting. And I know John is going to talk about gradient, the new gradient tool that PixInsight has. But the SETI Astro guy, and I see where he's coming from, why he wants to start at this new level. Well, the color was causing that. Okay. I've noticed that if you look at his script, which is AutoDB, I'm just going to go with default, so I'm going to execute it. It's almost done. And that's the gradient. It's just something I noticed this tool does that the others don't do. See how everything's lined up here?
Yep.
Whereas here we had a little, and when I do the PixInsight tools, they're a little bit off as well. But usually you solve these problems when you go to SPCC.
Right.
Right here. And then you just drag it there. But I think it's interesting that he decided to tackle it with when he did his extraction. Now the Merrill's point. Let's go get. If y'all remember, we did this particular project when we had that competition with the Astro Imaging channel.
Yeah, oh yeah. Huh?
And it's about ready to load. Hard drive fell asleep. All right. So this is really good data that he took. NGC 253, and it's mono. And he took some narrow band as well, but this is the RGB that was combined. and it's the same problem. So I decided let's look at the pixel math on that. And another way to do, you don't have to do the name. You can also do target. $T means target, which means it's the object is in the front the most in PixInsight.
Right.
And I'm going to go ahead and fire that up. And you can see that, it just, with the mono, it just seems to neutralize. It's already lined up perfectly. See how that? So I thought that was interesting. And Meryl, is that a little bit too little black for your comfort? This area here?
No, no.
You're very, okay. So yeah.
What I do, I'd put the cursor and then do the left mouse and move your cursor back.
Yeah.
Put your cursor back over the image.
Yeah.
Hit. Okay, what's the K value? Well, see that's linear, so forget that.
Yeah.
That's fine and linear, but when you stretch, I usually end up at 0.12 or 0.13 or in that range. For the K,
Yeah.
that tells me how dark it is.
Right.
But linear doesn't have quite the same.
Yeah. So this is a step you do in linear before you start stretching. Anyway, I think that's a good suggestion on Frank's part. So I'm going to start doing that.
Yes. Now the question is, when do you do the color calibration?
Okay, he has a specific order. He says you start with this formula right here,
Right.
the min formula. Then you get rid of the gradients as much as you can, using his tool or others. He has actually Graxpert in his system. You can use that as well. And and John's going to demo one today, and then actually there's another one that John's not going to demo. That this is a fairly new tool that does it, and all of our favorites that we've been doing for years is dynamic background extraction.
Yep.
So he says that's like you do that second, and then you go take care of the white balancing with the SPCC. And he's a pretty smart guy, as you guys know.
Yeah.
And I'm gonna. So that's any questions about that?
Totally makes sense.
Yeah.
But what you demonstrated is good for one shot or the multi-filter. I mean,
Right.
RGB.
I think it's a good first step.
Yeah, that's great.
Now I'm going to talk about this is their PixInsight's batch tool, which is the least intuitive process I've ever seen in my life. And it took me a while to figure this out. So I thought I'd share with everybody to reduce headaches.
So you're moving on to the next topic.
Yes.
There wasn't any other questions on this one.
Does anybody have any on that formula?
Well, everybody's quiet tonight. What's up with that?
Can't find the mute button.
Yeah.
Yeah.
Oh, now you found it.
Yeah, finally. No, that's pretty cool.
Yeah, it's a great first step. And it's so easy. I
Oh,
thought
yeah.
I just put it
Yeah.
out there. So there it is. Target, $T, target, minus min target.
Yep.
Now I'm going to use this instance to do another demo. I'm going to do the process. They're called containers. One's called an image container, and one's called the process container. And the image container is all the images you want to affect with the processes. And this is a very crazy, unintuitive way to do it. This is what I've discovered is the best way, at least for me. You can load any image to do like say you got 500 images you want to do the same thing to, and just walk away from it. And it's something that WPP doesn't do. So you just want to like maybe straighten out all your stars with Blur X, or get rid of some of the noise with Noise X. So this is the tool for that. And I'm just going to grab here's a let me do like a deconvolution tool like BlurX. I'm just going to drag it to any, it could be a photo of me, a JPEG of me. It doesn't matter. You just drag it. You just want whatever, every process you want to do. And let me get another process going, like a mini gradient correction. And this is happening before stacks, before calibration. So I just did 2 processes. And maybe, what if we wanted to do some curves? Let me do curves instead. Add a little saturation in the midtones. Drag it over. And then I just did that pixel math. I can just drag that over as well. So the way these containers work is crazy. They only work on what is called instances. And I can look at this Explorer, where is it? History Explorer. And you can select the only image up here that I drug everything to. And you see everything I did to it. I did the BlurX, gradient correction, curves transformation, and the pixel map. Now, this right here, this triangle tool in PixInsight is an instance tool. If I don't make an instance of this, none of this works. And there, there it is right there. An instance of that process. This is called a process container. Now that I have this, I can get rid of this photo. Don't even have to bother to save it.
That's amazing, because I've used this before, but I've had to drag them into the actual process container or add them to the process container. That's
right.
a good way of doing it.
It is. As a matter of fact, I'm going to hat tip Frank from SETI Astro on this as well, because I saw him do it. And then let's see. Now that we have a process, the easiest way to get the easiest way to get to the image container is right click and choose image container right here.
Right.
And I'm just going to add, like, you can add thousands, literally thousands of images. I'm going to add just 3. And they're there. And then I'm going to choose a output directory. Let's put them in result. So now I have my image container. But this is not an instance. So if I was to take this process that I just created, as you can see, and try to drag it here, nothing's going to happen. See the X? So I'm going to open up the image container and make an instance of it from the triangle tool. Let go. And now I have an image container and a process container. And the way you know that it's an instance is if you can name it. You have that little N tool. This one you can't. I can name it images, anything. Pre-process. So now I have the 2 things I need to do the batch. And now when I drag, you notice I have a check mark. And just think of the that alone, the BlurX, and just tell it to do a slight reduction of the star and do a correction of the oval stars. Just think how much better that might register. I think you have potential. If you do this before you even do WPPP, you have potential for everything just lining up better and less blur on the star and less halo. So it's something I'm experimenting with, and I hope to check back with everybody soon. But the way you activate, yes.
So you would put all your image files from all your lights, so your 100 or so lights or whatever,
Right.
to the image container and then move the process container to it.
Right. So there's BlurX. I did a
Yeah.
ton of them here. And you can delete these, like just say, I really don't want to do this one.
Yeah.
Okay, but the problem with this is you have to create a new instance. So I'm going to just drag this out and just name this simpler, less steps.
You can also disable the ones in there as well instead of deleting them.
Yes. So see how that still has 1, 2, 3, 4, and that only has 3. So now, Alan, you check everything's an instance, so it's going to work. I'm going to let go, and you can look down here at the
And run.
the
Okay.
console, and you can see everything's happening.
It automatically starts. Okay.
Yeah, just let go.
I guess you could do an initial dynamic crop on it too, if
Sure.
if the image is a lot, or the object you're looking at is a lot smaller than your camera frame size.
Yeah, that's a really good point. Like, think of what John was bringing up earlier. Like he has a ton of, like, say, M42s with different focal lengths. You could crop out some of the, and it'll process quicker. So
Yeah.
yeah. So cropping is one you can do. There's some things that it won't do, such as debay. So if a debay wouldn't work in a process container, because the resulting image from a debay is always a new one. It pops in a brand new file, so it's just that you have to do separately. So this thing's not the perfect way to do it, but it's a really good way to do it. But what if you ran a BlurX, and John, what if I ran a BlurX and a NoiseX on everything, and then I ran it through WPPP? Don't you think the chances are pretty high that it'll be a lot better stack with less noise?
Yeah. Especially with that correct only on the blur terminal.
Yeah. So it's something I'm playing around with.
Yeah.
Well, so I told Meryl this is going to be a quick one.
Well,
Does anybody have any questions about this?
well, I guess one that I've tried, and I think you answered it, but I don't think you can put scripts in the process container. Is that correct?
You can some.
What's the difference? What's the
Uh,
difference?
well, a lot of scripts, like, they call for, like if it's a simple script that does something. A lot of scripts call for interaction, and that you can't. Anything that involves interaction,
Yeah, yeah,
you cannot do, because then you have to be there and hit the button for all the images. But really, there's really no reason to have a script, because basically a script controls pixel math. That's basically PixInsight is basically pixel math. That's all it is,
right.
with things aligning up to help it. So since you can put the pixel math processes, you can just drag them in. Like, I can add 15 pixel math processes right now. That's the way to roll.
But there are scripts like the SETI Astro scripts that don't need. Yeah, I mean they're automatic.
Yeah, some of those would work, but some would glitch out just because, uh, you know, what happens is, like, if a lot of scripts involve creating temporary new images and doing some math on that, and then bringing that image back. So there's really no guarantee that they will work. It's just something you try, and you don't have to try it to 1,000. So I could just open up any photo here, and here's the process container. So I can see it. I'll just drop it here, and I can drop it in there, and it's either going to work or not. And
Right.
you only do it on one.
You have some
And
like statistical stretch or the automatic.
right. So you can drag that over there and then just okay, if it works on one, it's going to work on all, 5,000, whatever you choose. Are there any other questions?
No, that's cool.
All right.
Yeah, that is neat.
It's all yours, Merrill.
Okay. Well, what I wanted to do is just kind of I think John's done some work and I've done some work on the Bernard loop. Let me see if I can't get it to share here. Okay. If I can find my Pix Insight. You see my Pix Insight screen?
Yes.
Yep.
Okay, well, just the background for those who may remember, last, was it November you did this, John, where you did the demonstration how to use the mosaic process? Anyway, it's something on that order, November, October of last year. It's very cool. I'm sorry. Oh, I thought you said something, John.
No, I haven't.
Okay, well, so I just said we'll just use that as my methodology to do it. So my Bernard's loop for my camera and my telescope it had 15 panels, and I was doing LRGB, and I had to put a rotator that derotated because I have the alt azimuth set up there for my refractor. So I had 15 panels times 4. I actually had 60 panels to deal with, and it was a pain in the behind. But throughout the last month we've had almost no clear skies. But I did get an hour of luminance and 20 minutes each on RGB for all of those 60 frames or 15 panels. And I use the Nina process that I have a standard template that I just replicated 15 times, put the coordinates in and let her rip. And so every night I did the same 15 panels, which is different than what I think John's going to show you. He has probably a better way of doing it because they have a plugin that now does that. But so anyway, what John's process does, or it creates a big panel. You see the size of this guy here, and it's got the black background with that one panel. This is panel number 6, as it turns out. And then it positions it based on all the coordinates of all the others. And this particular panel, if we really zoom in, you can see M78 right here, which is kind of. And then I said, well, okay, that's kind of a neat one. So I said, well, let me show you this guy. Well, this is 6, 7, and 8, and these are the 3 stars. I mean, in this Bernard's loop here. You got M78. Come on. And you got the Horsehead, Flame Nebula. You can see the well, in the big picture, you can see the Orion's belt here. And then of course, you got Running Man and the Orion Nebula. And this was my favorite. Well, this is let me go with this one first. This is just a grouping of these guys, the 2 panels, and that's kind of neat for 20 minutes worth of RGB.
Wow.
So, but then it comes out to this. This is the 15 panels put together, and you can start to see the loop here.
Yeah.
I've got a bunch here. It's missing. It's just not enough time. And I was going to do some HA to add to it, but I haven't had the time. But again, you can zoom in on this stuff, and there they are. Which is kind of cool to me. And,
Wow.
but but here's the 3 stars of the Orion's belt. This is Orion's belt right here. And so right there's the horse head and the flame. And where I lost the M78, but it's right here's M78. That's frequently one that's taken image of. So I took that, cropped it a bit, and kind of processed it the best I could with this, but it's got the beginnings of some neat stuff, which I'll pick up next October maybe. So, but the thing that you got to be prepared for is if you have a camera that's got a lot of data. I mean, I had I consumed 350 gigabytes just for this, um, taking of the images and processing the images. And so it's a huge amount of use of your hard drive. And each one of these big frames here, this one, or the big ones, I guess, actually is 3.5 megabytes or gigabytes. I'm sorry. So it consumes a lot of RAM and consumes a lot of your hard drive space. But the beginnings of this, I'm gonna say, hey, it's worth it. I'm anxious to get a couple of 3 hours at least of each next year. But
So, Meryl, I understand you said you don't have a lot of time on it, but do other people have a lot of time on this? Are we gonna stack everyone's together that was working on the project?
we can, you can, but what you'll do, my guess is you got. How many of you took the loop part of it?
Yeah, I didn't. I just was able to do Horsehead and Orion.
Yeah, I mean, we can do that, but we've got good horse heads and Ryans already. To me, what's pretty fabulous is we can get
Yeah.
in the final in the final version. I would like to see the loop, which is, I mean, this is an immense amount of distance. I don't remember what the how many light years, but it's immense. But I don't think we're going to do anything of real high quality this season. I think we need to have this in mind as we go into next season, and then we can. Some people could take some more of this data down here and around. That would be spectacular. Then we could add all the horse heads, all the Orions that we have, and make one super duper 200-hour equivalent image.
Yeah. I'm thinking like maybe by the December next year or something, I might have like a wider field scope and I can definitely help out more. And then I also got to thinking about like just having like a 50 millimeter lens and just doing the whole thing at once, but that wouldn't get as much resolution.
No, well, and again, I think that the final product we aren't going to see this year. But next year is going to be would be good. I think we can start as soon as Orion starts to show up over the eastern horizon is when you need to take it, because the most I had when we started this was like 6 hours of imaging a night. Now, John, you did something similar. What you want to take over from?
Yeah, I mean, well, make a comment about if you're going to use a 50 millimeter lens to get the whole thing, which would be good because then you can use it as your reference image and be
Yes.
able to go in to actually replace certain pictures within it with the pictures that you take with the higher resolution. I actually saw a video on it. The guy is doing a mosaic of the Milky Way, basically, and he's got from Cygnus to Sagittarius or something like that. So he's got it all laid out. He takes this, the wider field shot to get his base star image down. Then he goes in with his high resolution and just starts filling in all the blocks and build it all out as you go. So you can use it as a good reference image to begin with. That'd be good.
It's a good idea. So he didn't move from Cygnus back to Cassiopeia. It's just on one side of the Milky Way.
He's been doing this for a few years now, and he's still working on it.
Okay, so he's heading that way.
Yeah, it's a lifelong project for him, I think, is what I have to go see if I can find that video. I can share it out on the
Yeah.
There was one. I'll show you this. What was on Telescopius? If I can find it here, share. Right. This is what's really cool there. You see that? You can,
Not yet. There it is. Ooh, wow.
Yeah, that's what I saw.
That's pretty cool.
that is really cool. Now, well, what I'm working on is just the kind of the half circle there. But I just think we ought to continue to gather data and put it all together next year.
Yeah.
And John, you've got some you want okay.
I bought a rotator barrel for this a project like this, but as soon as I bought it, we haven't had a clear night.
That's the reason why.
That's why.
I have 0 hours on that rotator.
Well, you're going to show us first light once you do, right?
That's right.
All right, I'm going to stop sharing. John, let's show us. Tell us what's different about your process of Nina, because what mine was just very linear. I mean, panel 1 through panel 15.
Yeah, I mean, well, I thought about doing that, but I'll show you here real quick what I got to deal with.
Yeah,
This is my layout. So I've got a 533 camera. So I have 63 panels to go through. So this is the bottom part of the loop, the other side, all the way up to the top, around the top area.
That
So
looks
you
like
have
that
your-
NASA stuff that Rick was showing us. Maybe maybe those were panels.
Now this is from this is actually I think out of Nina. I had to redo it because when I first did it, I did the Horsehead and M42, and I was going to build. And I didn't get the only thing I didn't get was the Flame Nebula. So this is that panel section here. So this is 7 out of 8 panels. So you have 1, 2, 3, 4, 5, 6, 7 up here, and then this would have been number 8. But I ran out of time. I was supposed to, this is all on one night. I did this. This was an hour per panel back when we had the 8-hour time frame. The problem I had was this panel here. It didn't go to the last panel. It got screwed up and kept going on this panel. So I think I missed a spot. And I was like, okay, I gotta find a different way to do it. So within Nina, there's a plugin. So basically, it's a target scheduler. And so I went through and added all 63 panels into different groups. So I got like a Barnard loop 1 or Barnard 1, 2, 3, 4, 5. I've got 14 in each panel, except for the last one, I think it's got 7. And what the target scheduler does is I can say 30, 60 degrees away from the moon. So if the moon's near, it won't deal with it. And when you build your sequence, you basically have a target scheduler item that you just add in. So what it does is you do your pre-stuff, and then you do, when the scheduler kicks off, it will go to find out what you got in your list. And it will find the best one to do and then start imaging it. So what mine did, so as I see the checkoff box here. So mine started, it started with panel 1. And then it went all the way down to panel 63. Then it did 62, then 61, then 60, then it did D. So as you look at this, if you think about how this sits in the west, the side it's working on starts to go down below the 30 degrees or 35 degrees I got cut off before the rest of it does. So it's trying to get those first. So it was going to slowly work its way up through the whole thing like that.
Oh, that's
So each one
smart.
of these, yeah. So each X on here is a panel that I've got at least an hour's worth of data on, and
Yeah.
I had to. Now the ones I don't have with the new sequence here is the Horsehead and M42 because I did these with a separate. It didn't show up here because I had to redo it to put all the 63 in when I did it through Nina. So it's slowly trudging through this. So all I got to do is basically I set the scope up, I do my alignment, the polar line. I will cool the camera. I'll do an initial focus, and then I just start this. I got a sequence saved for Barnard's loop or whatever, and then I'll just start that, and it will go pick it. It'll pick one of these panels and start imaging. And I got it set to do 20 images. I'm doing 3-minute shots, so I do an hour per panel, and it will dither each one. So when it gets done with that, it'll pick another one, go to there, and start imaging. And it'll just keep going and going and going. And usually you just like walk away, leave it alone. You know, I don't gotta worry about trying to do nothing. I got it set to where once the last item goes down below 30 degrees or 35 degrees, I think it won't do anything. So I had a secondary target, which was the M81, M82. So I was doing HAL03 combo with my filter on that target when this was too low on the horizon. That's why you see the background here. That's why you see a lot more red. That's a lot of the hydrogen alpha there for M82 there. So I was actually doing that in the background, setting it with 16 hours worth of that.
Yeah.
So what I've got so far, which I mean, the one thing about building a mosaic is if the panels don't touch, it doesn't really look too well, especially when you try to stretch it and stuff. So here's the bottom. There's 4 panels here. Then right above it is the 4 panels. Then you got 4 panels here. Then the other 2 other 4 added on. So this is 16 out of the. I think I got 18 panels. I think. Counting the ones that done prior, I got 22. I got 22 panels, and this is 1, 3, 4. This is 16 of those because the other ones are kind of scattered where they're not touching each other, and they're so it'd be like filling up the other little part of the gaps and stuff farther up. So hopefully we get a little more time because I looked at Nina. And it was showing M42 is not quite up to the so it's getting close. So like for the beginning of the night, you'd be right before it's right at the very top of the meridian flip, and you got after it. And I'm going down to about 35 degrees. So it would end about right around 22:12, 22:30, whatever.
So
And then,
couple 3 hours. Yeah.
yeah, so you get a couple 3 hours on it. So all I did in here basically, so you had to take the field of view and make it wider. So you got a bigger field of view. So you see there's Orion, there's the horse head, there's your loop. And then my little square in the middle there is my camera.
But
So I
this
had to,
this is the plug-in? Is that what we're
no, this here is just the regular framing wizard within
Oh, okay.
Nina. So I did 7, and then I did by, that's actually on my, that's the big scope. So that's 6. There we go. And then I think I did overlap of 10. I think I did maybe overlap of 15 this time. Then you just move it around to get it. So I like kind of offset. I didn't want to get Rigel here because it's so damn bright. You know, I figured to get the loop there all the way up to the top area. So that's how I kind of like framed it out that way. Then all I had to do from this point is basically tell it. So this you got all your panels here. And I just basically, you can add them to the sequence if you want, but you can also set up as a add target to a target list. And that's all I did is I clicked on that and it created 63 targets. Then I had to go in, which I don't know if I had the plugin here installed. I don't have any plugins here. This is just a bare one on my box. But you can go to there's a target scheduler one, and then there's another companion to it. But the target scheduler is you have to go in. It's linked to your profile. So you have a default profile, or you might have named your profile when you first start Nina for whatever scope you're using, and then you go in there. So it's going to be linked into that, and you go in and tell it, I want a project name. This is what I name it. Then you can start adding those panels to it. And you can give it a priority. You can say this is a high priority, these are low priority, medium priority. Then you can go and give it a. I probably have to need to do a whole presentation on this whole plugin thing. But then you have you have an imaging plan, so you can go in and say, okay, these are my exposure plan. So I've got 180 seconds set in there for the exposures, and you give it a filter name, and you can give it what it needs to do. And so when you pick your panel you want, you go down to give the exposure. You can say, okay, I need hour worth of luminance, hour worth of red, green, red, blue, HA, whatever you want to put. You can specify all that and just stick it in there and go to the next one and go to the next one. And it took me a couple of days to get all 63 stuffed in there. And then when I did, I just kept on adding more stuff. So I got like a Messier object list. So I've started slowly adding stuff to there. So I would look at when this goes down, I don't have to get up and go, oh, what's my next target? I need to go look at it like that. No, I'll just say, if it's up, go shoot it. The moon's nearby, avoid it. And it's perfect for you, Merrill, because all you gotta do is open a dome and let it go.
Well, it's not that
You know?
simple, but yeah. So did it plug in the coordinates for you?
Yeah, I mean, because you got once you do that paneling right there where I showed you with the grid layout of my mosaic, it showed you a list of all 63 panels, which gives you the center coordinates for each one of those panels. And so that's your target.
But
And it'll save each one of those individual one of those as a JSON file. And I just go add those back in, and then so it'll slew and send to that target. Each panel it'll slew and send to that panel, and then start imaging.
well, I had just one JSON file, but what this showed me, what I should, mine was a 3 by 5, 3 at the bottom and 5 up. What I should have done, just listening to you, I should have done the west ones first.
Yeah,
Moved east. I did east. Well, I just took it in order they gave me, which I'm sure was just random order. And it's for the bottom of the circle or half circle moved up, and I should have been doing the west ones first. Dang.
yeah.
Well,
So
that's good. That's good. I mean, it's good learning for next time.
yeah, so here's the so when you saved it, since it's SH2 276, once you saw the whole pattern list, you go there and set it as save it as a target. It creates a JSON file for each panel. So these are all the 63 panels right here.
Okay.
So those individual things. So you can select, one at a time if you want, but the target scheduler, you just add these into the target scheduler, and it'll pick the best one to do as it goes throughout the night. And so
Wow.
you can put multiple different targets in there. So it's like instead of just doing the loop, if you want to, that's why I put M81, M82 in there as a galaxy. So when it gets done, that was still up high in the north, and it can image it till nautical dawn or astronomical dawn, whichever way you go to. As I go through do that. So
That's
here's my sequence. Yeah,
right.
so then you can have I got a sequence here from it. That's my WR134 sequence that had that in there plus a couple of panels was before I started in the target sequence. And then I would have a I don't have I need to go find the other one. I have a sequence itself that's labeled as target scheduler sequence. And I don't know if I copied it over from mine. It's all over on my little bitty um, computer that's on the telescope, which is all turned off at the moment.
Right. Right.
So I have like a target. So all I gotta do is boot up, load Nina, connect everything, do the 3-point polar alignment, cool the camera down, do an initial focus, load my target sequence, target scheduler sequence that I've created, and it's got the pre and the post, and it's got the image in the middle, and you'll see the image in the middle there's nothing there. You don't have to copy any target over to it. It's going to pick the target and move over into the sequence automatically. So when it gets done with that, it'll just go to the next one. It'll just keep going to the next one. And if it loses signal or you get clouded out or whatever, and it'll give up, it'll try a different spot. It'll automatically try a different area to go out and see if it can find something else.
That's
As
cool.
long as you got, yeah. So my plan was I was going to put all 110 of the Messier objects in there, and get them all configured the way I want them to. I'm hoping to get a newer camera here soon, at least a APS-C size sensor, which that should bring my 63 panels down to like 24 or 36. It'd be like half, roughly almost less than half of what I got now.
Yeah, the other complexity is is getting the brightness of each one of those panels to be the same. I use that DNA.
Yeah, the DNA linear fit.
It, it was just it was so difficult.
Yeah, because you got to make sure each panel's touching each panel before when you do it, so it does better that way.
Well, then I
So I
got.
try to
Well, go ahead. I'm
so I
sorry.
try to, yeah, so I try to get the middle area, like the middle row is touching the panel each side, plus it's usually touching 3 below it or 3 above it. So that'd be like you can do 3, 4, 5, 6, 8 panels around it And once those panels done, you can pick one of those and then cycle off of that and just keep going around. But so if you only got like 2 or 3 panels, it's easy. But when you got 63, it becomes a chore. It becomes, why am I doing this? Because you got to do it one at a time. I wish there was a way you can go through and say, you know,
Yes.
here's the pair, then this pair, then this pair, then this pair, this pair, this pair, this pair, and then click and then just go do them all. But no, you got to do them a pair at a time. It's ridiculous.
Well,
And that,
but multiply times, I mean, you had 63, but I had 60 because LRGB. And trying to get those to do that by hand, I said, I'm just going to combine them and
Yeah.
do it by my eyeball and some measurements as if they've been stretched. So they're basically the same.
And the other problem I have is I was building that mosaic out of the what I already had, not that one. I'm already running close, but I had the whole section that's X'd out here, trying to get that built out. So when I had this one up here all by itself, well, once I got it all built and you go to stretch it, half of these become white. So you have all this dark area. This one became completely white. A lot of these got faded out because you got, there's no rhyme or reason to it. It knows how to really stretch it all out. So what I had to do is I pre-stretched the panels. I did like the easy soft stretch on it real quick, and each one in the same settings for every one of them. Then I was able to piece it together, and it went through a lot easier. Otherwise, I was struggling to get these two down here in. They're kind of somewhat faded because I think I got a little high level clouds going through, so I have to redo those 2 sets there.
Yep.
But trying to get them added into here, they would come in and look really wanky, really goofy looking. They were way off, and it's like, okay, what's the deal? And it was a struggle bus basically. But then I figured, let me pre-stretch them, then I add them together, and then it went through a lot easier.
Yep.
A lot better.
But that's why Adams, as we think about next year, we ought to take these learnings about those kind of things, and maybe we assign some areas that people can take, and then we can combine
Yeah.
them.
So I know I was a couple of years ago, I thought about doing the whole Orion complex of, the whole constellation Orion, but I was hoping to have a bigger camera to do it and maybe a little bit wider field scope. The 533 is great, but you look at each little panel size there just to do a bigger area. I mean, it adds up real quick, and it's like, it'd be nice like you to be able to do it in like 16 panels. Even if you had to separate RGB, combine them all together, and you got 16 panels to make your image set. But I got on my list here, probably end of the month or next month, I'll be getting, I should be getting my APS-C size cooled camera and a bunch of other crap. So
Cool.
hopefully I'll be able to.
Okay, this is
Nice.
this is the work in progress on this. Now, John,
Yeah.
you've got your presentation on.
Well, Meryl, don't get too comfortable with Nina because you're going to dump it pretty soon.
Why is that?
Well, the acquisition of PlaneWave there, PlaneWave is no longer PlaneWave.
Yeah, I saw. I mean, I saw the videos and everything.
Yeah.
I'm not so sure that's going to make.
Was I hear that software spectacular.
Which software?
The company they merged with, the reason why they merged is they had this. It's called
Outreach or something. Yeah,
Our Sky.
Our Sky. What? Okay.
Our Sky. Yeah, Our
Yeah.
Sky, I think it was.
Anyways, you'll probably be moving to that.
The Nina thing is really cool. It covers everything, and it's free.
Right.
Yeah.
That's I used to use Maxim DL, and Nina is more comprehensive and better than Maxim DL, and Maxim DL is like $600. Stuff stupid.
Wow.
Yeah, and they still got they keep on making a few more plugins in every once in a while for Nina, so that's where you get the target scheduler come in.
Yep.
And it just makes a lot more hands off. You can just sit there and just, go whenever you get a chance, have the computer, you figure it out, go take images of this, this, and this, and it'll work it out for you.
We'll give it a try. If the rest of the audience isn't using Nina, you got to really give it a try, and it's kind of
I think
cool.
I guess I'll make a little presentation on the target scheduler, and
I've got you written down already for future.
Yeah.
Okay, rock and roll.
Ask too much and you got to do it. So.
Yeah. Well,
all right.
You're very good at it.
Yeah, gradient corrections with Pix Insight. Gotta love it. And we got a little picture of Mars top left corner there. Yay. So we got gradient correction. Well, there is a gradient correction tool. I did my Crescent Nebula Wide Field. The real quick on this, top left one is the original stack, and I think it's just trimmed a little bit. Edge just cut off without stacking artifacts, and nothing done on the first top left. So that was the original stack. Bottom left is basically the default gradient, and that's what the difference is. You'll see there. One in the middle bottom is when you check off the box for simplified model, and you see a little bit difference. Then you uncheck that and then check the structure protection. Structure protection, you get the bottom right corner one. And if you combine both of those boxes, you get the top right one. So you see a little bit differences of the gradient as you go around, the original gradient, and then you get a little different variants as you go. So, woohoo, we're done. Good deal, right? But wait, what about me? You got Mars coming in now. So what is Mars? Mars is a multi-scale all-sky reference survey project. And this is really done by PixInsight. So they're looking to do a database of observable data from sky images that they're getting created out of southern Spain plus users submitted. And if you want more information on the Mars, I got 2 links there from PixInsight that discuss a lot more detail into Mars. So Mars, there's a Mars U survey, which is basically the user community. So this is where you can go out and submit your images into, and they will look at it and see if it's good enough to add it into the database. So they're looking for anywhere between 3 to 50 degrees of your field of view. Looking probably more for a cleaner skies, lower border sky area. And you can go to their website and you can build out. They're also looking for RGB images, color images, one-shot color, mono cameras, HA03, S2 images. They're sort of the minimum darkness. They really want border 1 to 4 area. They want it just basically completely pre-processed with master lights and just straight out of the stack, no other additional process. And so you got your calibration stuff and all that done to it, and then you hand it to them, and they'll take it from there. And then and they also do want the master lights drizzled, at least a 1x drizzle on it, or make life a little easier, I think, for them. So basically, you go out to your PixInsight, log into PixInsight. There's a spot for the Mars upload. So it'll bring you to where you log in. You use your normal PixInsight login, and then you go to this spot here, which is their multi-all-sky survey, reference survey. So you can go there and you'll see you're at the spot in them. You can go select your files and you can send a file, and that will basically upload them up to for them to be able to evaluate and see if they can add it into their users. So then here we have the PixInsight side. So it's an endless project for them. They're collecting more and more data. They have southern Spain, place called Astro Camp, where they're doing their imaging from, and they're using 50-degree field view camera, 35mm focal length. They're also doing the 15-degree fields with 135mm focal length, and they're doing full frame mono CMOS cameras, and they're trying to do full hemisphere coverage. So they're basically taking all this data and they're going to build one gigantic, lovely database. And they got so they're using to go along with the GIA catalog, or the G, I don't know how you really pronounce that. So you're looking at, they're seeing what you already have, what's in good skies, what the gradient is, match what you got to be able to remove the gradient from something that already has a really good gradient removed is really what it really boils down to. You go out to your distribution software spot for PixInsight, and you'll see under there is a Mars database files for XMars. The top one, which is roughly a gig in size, that is the PixInsight database. And then the 134 meg one right below it is the user contribution database that they've already accumulated, and they're still adding to it as we're going. So The user database covers what's in red. So the left side is the northern hemisphere, right side is southern hemisphere. Everything in the red is what they already have data on. And then you got what PixInsight, their data, they've covered most of the northern hemisphere. They got some gaps here and there. So you got the left side, there's the little dipper, big dipper over here. So the handle part of it, they got that, and I got it all around here, and this is all around the equator part. So I'm pretty sure they have to move a little farther south out of Spain to get all the way down to the southern hemisphere area. And this is what both of them look overlapped. So this is what the database pretty much contains between the two. And this is what your image is going to be compared to try to get the gradient resolved and removed, basically. So now you got new tools. So you have now you got a spectrophotometric flux calibration tool. And you also now got the multi-scale gradient correction. So that's got the little checkbox for the moment. So the spectrophotometric flux calibration is similar to SPCC, where you got to specify your filters. They do have a spot here for a gray filter now. So if you're doing like H2, hydrogen alpha, whatever, then you'll put that in your gray filter spot, and you probably leave the other ones the way they are, red, green, and blue. If you're using a one-shot color like I am, I'll go through and put in my Antlia filter for red, green, and blue, but I'll leave the gray filter alone. I've got a QE curve. I'm using my Sony 533 sensor. 571 uses the same. If you don't know what it is, if it ain't listed there, you can do the QE, the optimum QE curve and stuff like that. And then you can apply this to your lovely image. And I got a test guinea pig image of M51 with a lovely little satellite trail through and lovely gradients around the whole thing. So, and you'll see that when you go to apply this, you get a lovely little error message down here at the bottom saying that the image needs to be, it doesn't have a astrometric solution because it has to be plate solved. So there's plate solved data. Run it again, you get this loaded little graph. You got a red, green, and blue graph, and this is what this is it's basically measuring the intensity of the stars in your image. And it's going to take a subset of those and kind of create an average out of the red, green, and blue. So anything that's not in the gray area gets ignored. So if you got ones down here, maybe this, cloud cover come through or something got too bright, those get clipped off. So it's going to use the middle section for each red, green, and blue section there. And this basically gets added into, I think, the FITS header somewhere, or somewhere in the on the EXIF file. Sorry. In my case, the TIFF. It gets stored somewhere to be able to pull back out when the other piece of this runs. So now we got the multi-scale gradient correction tool. And first thing you want to do is, well, hopefully you downloaded the two databases. You're going to check the box. You're going to check the little wrench down here first. Brings this little box up. Click Add. Go to where your two database files you downloaded are. In my case, it was on my desktop here I'm using. Fun fact, do not put your database files of any sort inside the program files PixInsight folder area, because when you upgrade PixInsight, it deletes all that, which means you'll have to go redo all your database and stuff like that. So leave your databases outside of the PixInsight install area. You come over here, you got them plugged in, click OK. Then you come down here and you're going to select or click default files, and it will populate them into the list right there. So now we have our lovely guinea pig, and I've gone ahead and created 1, 2, 3, 4, 5, 7 previews here, because what we're going to do is walk through the tool. When you look at the tool here, you have, so I'm doing regular LRGB. I've already done the flux calibration on it, already got that. This is the default. On the left side is what the gradient starts with. Right side is, I got preview with that 1024. So we're looking at a gradient scale of 1024 and getting applied to it. And that's what's going to basically pop up what it does. So this is the gradient that is trying to correct from here to here. So you can see It's kind of smoothed it out some, but you still got some edges around it. So now I did it again, but now at a little farther down at 768, it creates this gradient. That's what it corrected. You can see it a little round. It's like, a little better. Then down at
Hey, John, can I ask you a question real quick?
Yeah.
Is it a good idea to crop a stacked image before you begin this process?
You can. I've seen the videos where it didn't matter really. It goes both ways because they're looking at your stars, they're comparing to the database to find the scale they need for the gradient removal. So they're not really touching your picture as much until they get to go to remove the gradient. So,
Oh,
but
that's
I
good
usually,
news. I like
yeah. So
hearing that.
my normal process I have once my image is stacked and it's come out, I usually do a minimal crop around the edges to get rid of that stacking artifacts since I drizzle or if you dither and everything's kind of a little shaky around, I usually crop all the stuff out that's not covered 100% across the whole board to start out with. But you really don't have to. I just always prefer to do that. But yeah, here's a 512 one. So this is the gradient. It's getting a little better. Still got little corner areas. And this is what the gradient looks like. And there is a reason why I'm doing this. And you're going to want to do a similar thing on your images in the beginning. So now I'm down to 256. There's the gradient. Then here's 128. And now you look at the gradient, look there in the middle. That is actually part of the M51 galaxy. So now the gradient correction is trying to do is now going to start building into your little small structure there. Because when you look at the gradient scale, the lower you go, the smaller structure size you're hitting. The higher you go up above 1024, 2048 and all that, you get into the bigger scale area. It's using a bigger window type thing to go around and look at everything. So for this, I would probably pick 256 and do the image correction on. Just as a point of thing, I went over to, this is the 2048, which is one above it, above the default, and see what the gradient looks like. So you see it's not as good as the other ones. So basically, I just chose the 256, applied the gradient to it. So it did pretty good. Leave the galaxy alone. Star Trail is still going to be there. I mean, this is just a test guinea pig image. So there was, clarification of some important concepts that I ran across from Vincent. He's actually one of the PixInsight guys, and he was just adding some important points to the end of this whole thing. But this is a whole little message that he had on one of the forums, I think in the PixInsight forum. So basically, he's posted a message address some of the difficulties the users encounter understanding the working with MGC. MGCMRs are a solution based on observational data. Always keep this in mind for the moment, as the available Mars bands are luminance red, green, and blue, and hydrogen alpha. So if you're going to use O3, it might not work. It might work on the user side, might not work on their side. But there's still data that's always being added to it. So by the time you get around to doing it, some of this other stuff could actually be added in as we keep going. So they're slowly building that database out. It's the same thing if you got dual band filters. So if you're using, since that's one reason I used M51 as a guinea pig, because that was shot with, I think, the L Pro filter. If not, it was just a straight, that one would have been the L Pro filter on that one. Otherwise, if I were to use my HA03 combo, it would have been HA only, because I don't think it would have found anything for O3. So dual band filters are difficult to correct now, but they're slowly getting there. It's almost like this was not ready for prime time, but they've had to get something out, show the progress of something somewhere, whatever they're doing. So it's going to be a work in progress probably for the next year or so or longer. So the gray filter in SPFC and MGC, they included 4 filters, make it easier for your tool configuration, which includes your RGB. If you work with grayscale, you want to change the configuration of the red filter. So if you're going to use like the HA, you want to specify that. It does not replace SVCC. Both tools use GIA's spectrophotometric data. Each tool does very different things. SPFC calculates how bright the stars are in the image and adds new metadata defining the brightness. So it doesn't change at all the image. It just basically adds metadata to your image. SPCC measures and corrects the color in the image, so it will make changes to it. And they're basically saying just don't underestimate the power of MGC as a collaborative tool. You may not want to upload your images to our Mars U server, but you and your friends, you want to help out, blah, blah, blah. So, um, so basically, they're trying to do is correct narrow field images with wide field images. And a side effect of that is if you yourself have a narrow field image and you got a wide field image, and the wide field image you've already got corrected, you can actually use that as your base image to correct your narrow image, your other images, your more zoomed in image. Basically, you can actually use that if it's already been well corrected with the gradient. It'll base it off of that instead of going to their database. It'll use your own image to manipulate and take the gradient off the other one. But yeah, you can go out there and there's spot to go out there and read it. So here's the YouTube videos. You got the multi-scale gradient correction tool 1 and 2. Those YouTube spots. I think I posted those in the Slack channel at one point. And there's also a multi-scale gradient correction tool, main optimization parameters as well. And I think the last one here was, I think this might have been City Astro when he went through it as well. I don't think I forgot to put the title in. Demos. Any questions so far? That is the last slide right there.
Quiet group tonight.
That's good. I'm gonna have to share a different screen.
Before you, does this take a crummy background and make it better, or just takes your crummy background and make it as good as it can be?
It's trying to make it as good as it can be.
Yeah,
I hope
when you have modeling or some modeling, it doesn't take correct any of that garbage.
I think it tries to. Let me bring that inside here. So everybody can see my screen.
Yep.
Yes.
This is on a 4K monitor, so a 4K TV. So there's my lovely little guinea pig of 6888 Crescent Nebula. I've already did a solution to it. So astrometric solution's already been done. I believe I did a photometric flux calibration on it, but I can do it again. So I've got basically leave the gray filter alone since I'm using Antley ALPT filter. So that's my red, green, and blue. And just basically go and just drop it on. And this is going to pop up your little graphs. Let me get around to it. I should have restarted PixInsight and all that crap. I did this, but it's been running for 5 days now. Slow. Oh. This will pop up here. So there's our little lovely star chart. Basically, there's the red scale. So it's going to use in this little section here to find the average it needs. Same thing for the green. So anything above this and below it gets chopped off. They're not going to worry about that data. So if you've had cloud move through, phantom lights from somebody else or something like that, made the stars a little brighter. So it kind of, so I think their thinking was if you have a variable star that you're doing a long exposure on, it's going to get dimmer and brighter if it's real fast. So it might skew the data a little bit, depending on what time frame if you've imaged it. So they're going to say, just give me the smaller average there. So it's just like the SPCC, just close it out. Now we got our corrections. So usually go by the default, which is set 1024, structure separation of 3, and then your scale factor down here of 1. And just basically just apply it. And this is a chore I have been doing for the past several days over and over and over and over and over. And you basically will wear yourself out doing it. And so you'll see it goes through here. You see these are the pictures it pulled for red, green, and blue section that it's using to calculate out to get the gradient. Like background extraction is trying to guess what the gradient is when you put all the points out there all around the circle. So they're trying to guess the gradient to be able to extract it out. This is using, actual data from pictures and comparing between yours and theirs to pull the gradient. So this is the gradient. You gotta love it. If we make it a little smoother. And what you really want to do is you want to really just go around and look at your samples as you go around it. So if you're looking at down here in the middle bottom, you'll see the red, green, and blue. So it's like 0.43, 0.27, 0.24. But as you go around, it doesn't really move a lot, even through this section here. So you don't have really much of your structure, because if you had your structure in here, they would shoot up a lot higher. So you know you got structure that shouldn't be getting.
Look
And
how
this is-
complicated that gradient is.
Yeah.
You cannot achieve that with DBE.
Oh,
Now,
yeah, that's crazy.
yeah. Now, it can do more complex gradients, but you may have to do it in like two different shots. The one thing you can do, I mean, so if that didn't work out, so you can see the difference there. You can see, and then you can see a little bit of the gradient as I flip back and forth between the two.
Yeah, it's interesting.
So, like, if you wanted to go down to like, what would 512 look like? I mean, so I sat here with going through the different settings and just doing things over and over and over. And some of them I actually struggled with, and some of them I had no problems with. I think my jellyfish nebula, it was hard to try to get it where it wouldn't do any structure. And then the what was the other one I did? Can't think of it, but this one here, actually, I figured it'd be just as hard, but it's actually a lot easier. Just the default on it worked. But it may not work for you. That's why you want to look. You always want to look at your gradient that it pulls out, and you really want to go through over it and look at the values, the green and blue values on it, to make sure they're all really super low across the whole thing. If they're all super low, you probably got the good gradient. You're good to go. If you got a big heavy spot where you may have pulled structure out to like this here. So that's what we got here. 2, 4. Yeah, now they're coming up a little bit. So if I go any lower, it's going to start building more. It's going to take more and more out of it. So, 192. But you also have like scale factors. So you can, I mean, this tool can be really, really fine tuned. Let it go. But you'll see like in the middle area, you see it's kind of overcorrected the crescent area. Now I'm going to do it again, so it's going to really overcorrect. But so you can see where your structure's at, look at the gradient, find out if there's structure in it or not. Is it, then you may have to back off. So you have to fine tune the gradient scale. So even though you're starting at 1024, you go up or low. And since I got small structure here, I'll go lower and then check it. Keep going lower and check it until structure starting to get picked up, that is starting to over, and you back off a little bit. Then you can fine tune it with the scale factors. You can actually bring these up or down, and then try to get the best gradient you could get removed. And when you look at the YouTube videos I have listed, at least on when you go to the Pix Insight one, they go through M45, the Pleiades, and it's got a really complex structure through it, and the gradient is very complex, and they go through and they make it look fairly easy as they go through, but they just go and you walk through the factor part. They walk you through the gradient scale, the structure separation, to try to get it down. I mean, to me, more time trying to fine tune the gradient than you would if you just did automatic DBE and be done. go through and just pick 12 freaking points around the corners and inside and let it do on the dynamic background extraction or something.
Well, that might be okay with galaxies, but with nebulosity, this tool will really improve things.
Yeah, see now I really overcorrected
Ooh,
and from the gradient. Yeah, so that's most of your crescent nebula right there. So yeah, so you would back off and not go that far down. Even though I had to do it, I did it twice. So go back to where it was. Next one should be the multi-scale. So yeah,
Well, Steve, you
should
think you
be
talk to your
spectral.
city astro friend and get this just one button push, get all this done?
I'm
yeah,
thinking it would be nice to have Frank be able to look at this. In
yeah,
fact,
you can probably do something with it.
Frank has already seen this. He's already done this. In fact, he's already got a video who went through and worked on it. And I think his conclusion pretty much was it's good, but you're going to put a lot of time and effort into it to get the results that you want out of it. At least at in where it is now. And once they get more and more data along, because it's missing some data for certain wave, like O3 data is missing or S2 data is missing. So you can do HA and a lot of the RGB stuff, but there's certain parts of the sky that they haven't covered yet. And as they cover the whole thing and keep adding more and more data to it, I mean, I think eventually the multi-scale gradient correction tool here will probably get revamped and look a little different to where if you just load the Mars databases in, put your filter sift in or whatever, and just click go fetch the gradient, and it'll remove it. And it'll go through and see how many pictures there are, and it will average out the ones it likes. If it doesn't like it, it'll just ignore them. It'll reject those, but you'll see the list. And so like
Yeah.
this one here's got 1, 2, 3, 4, 5, 6 of them for blue, and there's so you got red, green, and blue basically. So there's 6 there. You got 6 there. So there were 6 reference photos it was able to pull out of the database to compare against my wide field shot here and try to get down. It was trying to calculate the scale it needs from the SPFC. Goes out and look at the pictures and builds that model off of all that, and then extracts it. Then it might not be perfect. It might be off some. And that's where you have to go in and go, well, I didn't like that. Then you have to come down and start tweaking it. So you'll tweak with the gradient scale. You can go to default's 1024. You can go higher. You need to get, if you got larger structures, you want to go higher up. And then you got scale factor where you can, if you're going to do a scale factor, your best bet is to click on one and hold the control key down, or I don't know what key the Mac uses. I think it's their little Mac key or something. That way it'll move all these in one shot. So you might go up to 1.5 and then redo it, see what it does. Look at the gradient. If it's making it even better or not, then it may be worse, and you go down the other way. And you can slowly fine tune this. And I think one of them they go through and they actually went through and fine tuned that down to make, it's on the more complex gradients you'll start fine tuning the scale factors, you'll fine tune the gradient scale, the structure separation, and all that. I mean, so you might spend an hour trying to get a gradient out. Whereas I'm used to, I want to push a button, throw the gradient out, I'm good to go. If you take a little bit of the nebula with you, I don't care. I'm good to go. I'm not looking to have 100% of the data if I have to. If I have to spend an hour or so trying to keep 100% of the data, I would probably give up.
Yeah.
But
AI's scanned all these photos by now, and eventually they're going to do. You won't even have to tweak those settings. Artificial intelligence is going to
yeah,
just one button.
so this is the same one here basically. So let's see. That was the gradient that got it pulled out. This is one of the iterations I did. And then I did this one was with the SETI Astro um, automatic dynamic background extraction. So you can see between,
It's a huge difference.
yeah. So you're looking at left side is the gradient tool, right? And the right side, left side Mars, right side is the SETI Astro. So this was the City Astro. This is the merge gradient, and this was City Astros. So they're fairly close when you really think about it. When you look at the different shadings of them. So you like the dark spot down here, you got dark spot down here, it lightens up, lightens up. It's a little darker here, it lightens up over here. You got this up here. So you got, similarities between them. You got the dark spot up here, you got the dark spot over here, lighter spot over here. This has got a darker spot across a little arc here. It's got part of the arc. You got the little up this way and that. So it's got that over here is over here. This one's kind of maybe overcorrected area right over here compared to what's over here. Actually, that could be a copyrighted dust donut right there. I think it's same thing over here because I know on one of the, I think on this one on the wide field, I think I recognize that spot. But I mean, overall, between what SETI Astro gave me on the right side and compared to what the gradient tool on the left side gave me, and they're fairly close. I mean, when you look at the end results, they look pretty close between the two. Now, I mean, you can go through and nitpick this all day. It's a little bit darker through here compared to here, a little lighter here, a little darker here. I mean, I would take either one of these really. I mean, I'm not looking to do any Astro photo awards or anything, Astro, picture of the day stuff. I'm not worried about trying to do anything like that. I'm just looking, making sure it looks good to me. And a lot of this really, the way this tool is right now, it really comes down to your eye and does it look good for your data?
Right.
What works for me may not work for you on the same data. So if you took your Crescent Nebula in this type of wide field, but a different camera, maybe just a little bit wider, maybe a little bit more narrow and stuff like that, and even with the same filter, we could probably end up with two different results using the same tool. Because you might see a little bit better gradient correction in one spot where I don't. Because I mean, now my eyes ain't the greatest, so it's like I see the lighter side over here compared to the darker side there. But to me, between the two, the one on the right side, I just ran the default, SETI Astro automatic dynamic background extraction. Just loaded it and clicked it. That's what it spit out. Left side, I spent probably 30 minutes or an hour going through tickling things to get it. I was playing with it so damn much, I got to the point where it's okay. Let me go back and just do the default work. So it's actually with the one click on that one as well. So it did pretty good. But others I had spent hours on. I mean, I could never really get my jellyfish to look really good. They would always get either way too overcorrected or not corrected enough in spots. And it had a similar gradient like you see in M51. Which I don't know that one. So this is the finished version of that. But it had the bigger circle area. And that's the other thing was on the big vignetting that you get. It can correct for that. It corrected this one actually pretty good. And I've seen the other examples in the video they go through where you got a big massive vignetting around the edges. 3 edges look really dark, one edge maybe not as dark, but you see that big telltale circle and big old spotlight in the middle. And they were able to correct the image and everything, with the grading and everything like that. It just takes a little time to finagle through it. And one of them, he had to do it twice. He had to go through and get it to a point where, okay, it looks good, but now let's run it again. In other words, don't try to do it in one pass to get the complete gradient out. If it's really, really complex, you might do a 2-pass gradient removal. And it was able to go through and work it out and look pretty good after all. But some of it comes down to how much patience you got to sit with this tool to play with. Sometimes you might feel like you're lost. So you definitely want to watch the videos, the 3 or 4 that I got in the presentation. You want to walk through them a couple times, get familiar with it, and play with it. Who knows? You could be the gradient master by September.
Okay, we need to wrap up here. John, fabulous presentation like always. Any final questions for John before we finish up this evening?
Well, I like it, no question.
Lots of good information, Steve, John, both of you. Really good stuff. Any last comments for the evening? Any suggestions besides John do some more presentations in the future?
Yeah, I'll do the Nina target scheduler. I can do that.
Any needs from folks that we'd like to explore deeper for the future meetings?
I think somebody needs to do a run through of City Astro Suite eventually.
Sound like Steve wants to do that.
Yeah.
So,
Oh,
well, I haven't touched it.
Yeah.
yeah.
Neither have I. Come on. I didn't do nothing with mosaics, and you talk about it too much. And next thing you know, you get voluntold to do it. So
But you did such a good job. And I used your presentation.
I've had to go back and look at it again a couple times for certain things.
Well, and that's what this video.
Yeah.
I'll render it here tomorrow and post it, but it's such
Maybe, Meryl, maybe Brian Duke will do that City Astro. He's using that. That's sweet.
that was exactly what I thought when you said that. But
Yeah.
he didn't join us tonight. He said he wasn't gonna.
I'd ask him, and if he says no, he says no.
I'm not bashful about asking. Ask John.
Yeah.
So, okay, guys. Great evening. I'm going to go ahead and stop the recording here. Yeah. Good meeting. We'll do it again in March. And let me see if I can find the stop. Here it is.